This is the introduction to complex numbers. Complex numbers include imaginary numbers, which is represented by the letter I in italics. Imaginary numbers appear when you have a negative inside the radical. So for example, if you have the square root of -1, it becomes I. Complex numbers are written in the form of a plus bi, where a and b are real numbers and I represents the imaginary. So you will have 3 plus 5i, where 3 and 5 are real and I is imaginary. You will also have -3 minus 6i, where -3 and -6 are real and I is imaginary. If you just have bi, then it's called pure imaginary. So if you have 5i or -15i, these are pure imaginary numbers. With complex numbers, you have certain properties. You can add, subtract, and multiply complex numbers. With 5i plus 3i, you can simplify it to 8i. 9i minus 13i can be simplified to -4i. Think of I as a variable where you're just combining like terms. When you multiply complex numbers, something happens to the I depending on what its exponent is. I to the first power is just I. I to the second power is equal to -1, because we need to represent the square root of -1. The square root of -1 is I. Therefore, I times I is equal to -1. I to the third is -I because you have I squared, and we know that I squared is -1. And -1 times I is -I. I to the fourth is 1 because I squared equals -1 times -1, which equals +1. And then you have I to the fifth, which is equal to I, because you have I squared times I equal to -1 times -1 times I, which equals I. Using this rule, you can now find what I to the 12th power is. To find out what I to the 12th power is without going through the pattern, just do 12 divided by 4, and you get 3. So you have to find out what I to the third is. I to the third is -I. One more example, if you do I to the 21st power, always divide the exponent by 4. 4 cannot go into 21 evenly, so we have to find the remainder. So we know that 4 can go into 21 5 times, with a remainder of 1. This one remainder refers to the exponent of the imaginary. Therefore, our remainder of 1 will be just I. If you have any questions, please see me after school or before school. The last slide is just a summary of the previous slides, where for any positive number a, you're going to have the square root of -a, which becomes the square root of -1 times positive a, breaking apart square root of -1 times the square root of a, and anytime you have a negative inside the square root, you pull out an I. So same thing here, it's -1 times square root 5. The square root of a -1 is I square root 5. And this is just emphasizing down below what a complex number is, a plus bi, and what pure imaginary numbers are. Pure imaginary is just bi. If you have any questions, please see me after class, and I'll get back to you.